What is the purpose of floor polish? It protects and waterproofs a floor and makes it shine. Unfortunately, it also makes the floor slippery, which can cause accidents. We want to make a floor polish which does the good things we need it to do, but doesn't make the floor too slippery. In other words, we want a floor polish which gives us a fair amount of friction to stop us slipping. We can make floor polish by mixing molten candle wax with paraffin. At the end of the movie, we'll tell you how to do this yourself. But the problem is, in what ratio should we mix the candle wax and the paraffin so that we get a less slippery floor polish? So our focus question for this investigation is, how does a polisher's amount of candle wax affect the amount of friction the polish gives? The independent variable in our investigation is the polisher's amount of candle wax compared to paraffin. So we must have at least 2 treatments which differ in this respect. We will have 4 treatments. Each will have the following amounts of candle wax compared to paraffin. Treatment 1. 4 grams candle wax per 20 milliliters paraffin. Treatment 2. 8 grams candle wax per 20 milliliters paraffin. Treatment 3. 12 grams candle wax per 20 milliliters paraffin. And treatment 4. 16 grams candle wax per 20 milliliters paraffin. Towards the end of the movie, you will see how to prepare each of these, in case you want to do this investigation yourself. Our dependent variable is how much friction the polish gives. Friction is a force which resists motion. It results from surfaces rubbing against one another. Amount of friction is affected by how hard the 2 rubbing surfaces are pressed together and how rough each surface is. Therefore, the friction between an object and the surface it is resting on can be reduced by making the object lighter, tilting the surface, or by making the surfaces smoother. Some polish makes a surface smoother. We need some way to measure amount of friction. We need an indicator. If we have a plank and place an object on the plank, the object does not slide. If we gradually tilt one end of the plank, the slope will eventually be steep enough to make the object slide. When more friction is present, you need a steeper slope before you'll get the object sliding. We are going to use the minimum slope angle which causes sliding as our indicator of amount of friction. We're going to use 4 planks. To each we're going to apply one of our polishes on the plank surface. We apply polish 1, which has the least candle wax in it, to the first plank, polish 2 to the second plank, polish 3 to the third, and 4, which has the most candle wax in it, to the last plank. We want to know which of these polishes gives the most friction. To find that out, we will use a protractor to measure the minimum angle which causes sliding for each treatment. We place the first plank against the edge of a table. We place the object on the plank and gradually raise one end. We want the smallest angle at which the object starts sliding, so we stop the moment the object starts to slide. We then measure the angle the slope makes to the horizontal. We use a protractor to do this. Make sure that the protractor is positioned like this, with its origin on the pivot point. Make sure the protractor's horizontal line lies along the table surface. Read the angle which the bottom of the plank makes to the horizontal. This is the minimum angle causing sliding for this treatment. We record this measurement into our table. Before we repeat the process for the next plank, we first clean the bottom of the sliding object. This is important so that later measurements aren't influenced by earlier measurements due to some of the wax making the object smoother than it would otherwise have been. After this, we test the plank which has polish 2 on it. We clean the sliding object and then we repeat the process for the third plank with polish 3 on it. And finally, After again cleaning the object, we repeat the process for the fourth plank with polish 4 on it. In any investigation, it is important to make sure we have a fair test. We must make sure that the treatments are treated identically in all ways except for the independent variable. Controlled variables are those variables which must be kept the same between treatments to make the test fair. Friction is affected by the smoothness of the surfaces. Of course, the smoothness of the plank depends on which wax we use, which is related to the investigation's independent variable, so that can't be controlled between treatments. But the smoothness of the sliding object must be the same between treatments for the test to be fair. Friction is also affected by the mass of the sliding object. We used the same object for all treatments, and we cleaned its bottom surface each time. So the mass and smoothness of our sliding object were controlled variables. Candle wax and paraffin were used to make the floor polish. They are hydrocarbons. Hydrocarbons consist of chains of carbon atoms bonded to one another and to hydrogen atoms. At higher temperatures, these chains have more kinetic energy, so they flow over one another more. At lower temperatures, the chains flow over one another more slowly, so they resist flow more, so they are more viscous. Viscosity refers to resistance to flow. Viscosity might affect friction, and so temperatures should be controlled between treatments in order for the test to be fair. Here is the data we've gathered, represented in a table. Notice that we have a column for the independent variable and a column for the indicator of the dependent variable. We give each of these as labels in the column headings, and we include units in the headings, not the body of the table. In this column's body, we give the details of our 4 treatments. In this column's body, we list the measurements we took. Remember to include a heading at the top of your table. The heading should include both the dependent and independent variables in a logical relationship. Here is a graph of the data. The independent variable must be plotted on the x-axis, which is the horizontal axis. The indicator of the dependent variable must be plotted on the y or vertical axis. Make sure you use a uniform scale. You must use equal increments for equal distances on the graph. Also be sure to include a label for each axis, together with its unit. Data points must be plotted accurately and a smooth trend line drawn. Finally, don't forget a heading, which should include both the independent and dependent variables. What does this data tell us? To answer this, we need to understand the relationship between the indicator of the dependent variable and the variable itself. The indicator is minimum angle causing sliding. The variable is amount of friction. Which angles would tell you there was more friction? The greater the angle needed to get sliding started, the more friction there must be. When we look at our data, we see that polish 4, which had the most candle wax in it, needed the highest angle to get it sliding. From this we deduce it offered the most friction. We conclude that if you want a polish which doesn't let things slip easily, in other words, which offers more friction, we need a high amount of candle wax per volume of paraffin. We can say that increasing a polish's amount of candle wax increases the amount of friction the polish gives. Finally, let us look at how you could prepare the different polishes so that you could do this investigation yourself. Use 4 small containers. Label them 1 to 4. Use a measuring cylinder. Pour 20 milliliters of paraffin into each of the containers. Close the containers so that the paraffin does not evaporate away. Cut a candle into 1 centimeter long strips. Each will have a mass of approximately 4 grams. Use 4 glass beakers. Label them 1 to 4. You need 1 4-gram piece of candle wax for treatment 1, 2 pieces for treatment 2, 3 pieces for treatment 3, and 4 pieces for treatment 4. This corresponds approximately to 4 grams, 8 grams, 12 grams, and 16 grams of candle wax for each of the treatments. Using a knife, shave the pieces of candle wax into the relevant beakers. Now place the beakers on a stove or hot plate. Allow them to stand there until the candle wax has melted, stirring occasionally. Notice that beaker 1 has the least candle wax in it, and 4 has the most. Remove the beakers from the heat, being careful not to burn yourself. Mix the molten wax in each beaker with 20 milliliters of paraffin. You could do this by pouring the paraffin into the molten wax and then pouring the entire solution back into the container the paraffin had been in. You now have your 4 polishes. Allow them to cool. As they do so, each will harden. When they are all at room temperature, you can begin the experiment as already described.